Hello and welcome to factoring. You must understand that factoring is multiplication going backwards. So when we talk about polynomials, all of the methods that we use to break apart polynomials into their individual factors really stem from what happened when we multiplied. There are 5 methods of factoring. Now, if you have not learned these methods exactly, we would ask you to learn them so that you can be helpful in supporting students in what they are learning in classes. The first method of multiplication they ever learned in multiplying polynomials was distributive property. So undistributing is when you pull out the greatest common factor. Now, you should note that this works on all polynomials. So no matter what, you should try to pull out a greatest common factor. It's the easiest thing to do. So if you have something like 15x to the 7th plus 20x to the 6th plus 30x to the 5th plus, and you can see there's going to be a 5x to the 5th come out, or if I do something like this, 35x to the 4th, you're going to pull out a 5x to the 4th. And notice it didn't matter how many terms. This greatest common factor can happen on all of them, so you should use it on everything. And all you do is pull that greatest common factor out. So you're left with a 3x cubed plus a 4x squared, dot, 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 dot. Good. The second method. Now we talk about not just a monomial times a polynomial, but what happens when you start doing binomials. Well, you guys remember what happened when you did something like 3x plus 7 times 2y plus 3. Yeah, you remember something like this? Yeah, you bump that through, and there was an acronym that was used before, and you got 6xy plus 9x plus 14y plus 21. Well, if it ends up with 1, 2, 3, 4 terms, we know that the only way to get there is by multiplying a binomial times a binomial. So this had to be broken up into 2 halves. The second step is grouping. And this works all the time if you have 4 terms. Well, only on those that have 4 terms. Now, there are some 4-term polynomials that this won't work on, but if it has 4 terms, you try grouping. This is how grouping works, and maybe you haven't seen it before. You start out with a polynomial like this, and you saw it right in half. You look at this first binomial and see if there's any common term. Yes, there's a 3 and an x. Oh my goodness, look at that. There's a 3 and an x. And what's left is 2y plus 3. Oh, look at that guy right over there. Now in the second half, you'll see you can take out something else. And yep, there's a plus 7. And you get 2y plus 3. Now do you see what happened? You now zoom out and you have a common factor at the front and at the back. And you can pull that out. I'll pull it out right here. And you're left with a 3x right there and a plus 7 right there, and we have undone FOIL. So that's why it works with 4 terms. You cut it in half, look at each binomial individually. When you do that, you get the same thing here if it is factorable. Sometimes it may not be, but if it's the same thing, then you're able to continue factoring. Good. Now let's consider something like when you had x plus 5 times x plus 7. Do you remember the shortcut that happened? Certainly x squared. Then you had plus 7x plus 5x. That was plus 12x. Hey, 5 plus 7 is 12. And the last one was a 35. So the third method is, I'll call it trinomial fast. This is a trinomial which starts off with just an x squared. The leading coefficient is 1. Sometimes they'll write an a here and write a equals 1. But we'll just leave it off for now. This is the nice fast one. You know it had to be an x and an x, and then all these had to do were add to b and multiply to c. So normally you'll take the factors of c and write them down here and select the ones that add to b, and those are the ones that go right in there. Okay, so that's a trinomial that has this in the front. Now, if you have, I'm going to call this one try slow. If you have ax squared plus bx plus c, this one's a little bit tougher. For example, if I start off with 2x plus 5 times x plus 7, Notice that this 2 really messes things up as far as what's in the middle. So you'd have 2x squared plus 14x plus 5x, that's a 19x plus 35. Notice nothing times together to give you 35 and adds to 19. It was this 2 that messed up those middle terms. So how does it work? How does it work? Well, this is called the AC method. You take A times C. In this case, you would take 2 times 35, and that gives you the number 70. Now let's write out the factors of 70. That's 1 and 70, 2 and 35, 3, no, 4, no, 5, and 14, and 7 and 10. You write all these out. Do you see any of these that add up to 19? Oh my word, there they are right there. Now notice that these are not what end up here. There's not a 5 and a 14. This is where this guy came from. And it really is. It's 2x squared. It was plus a 14x plus a 5x plus a 35. That we actually undid it by multiplying the A and the C, this guy right here and that guy right there. You've included both of those, so when you look at all these factor pairs, that's all the different ways that these two sets of factors can line up. So yeah, 5 and 14, and we broke it apart. So now how many terms do we have? 1, 2, 3, 4. So this guy, you look at the factors that split B. Yeah, they have to add up to B, exactly, with positives and negatives. And then we now have 4 terms, which means we now group. Okay? So this, you cut that in half, and you now have 2x, x plus 7. And over here, take out a 5, x plus 7. And when you pull that out, you get x plus 7 times 2x plus 5 right there. So we undid the combining of like terms and then the FOIL that happened between these two binomials. Awesome. So the fifth method, special cases. Alrighty, these are the fun ones. Yeah, and let's go back and look at see what happened with multiplication that was a special case. If you have something like x plus 3 times x minus 3, you multiply those just fine and you get x squared minus 3x plus 3x. The magic happens and the middle terms vanish and you're left with difference of squares. We ended up with a binomial from a 2 times 2. We should have gotten 4 terms like FOIL, but it didn't happen. The middle 2 canceled. So there were special conditions that allowed this. These look exactly the same, but you have one plus and one minus. That plus and minus difference, and you can try it with something like 3x plus 7 times 3x minus 7, as long as they're the same except that middle term. They're actually called conjugates, and we'll come back to that word in a little bit. But when you multiply them, you get 9x squared, then you get up minus 21x plus 21x minus 49. Some things you should note. Number one, this sign is always negative. Always negative. If it is a positive, then these two signs were the same and the middle terms could not have canceled. So going backwards, these are negatives. The other thing is that this number and that number have to be a number times itself because these two have to be the same except for that middle sign. So 3 times 3 is 9, 7 times 7 is 49. So they will call this form a difference, meaning a subtraction, a difference of squares. Because that's a perfect square and that's a perfect square. And so yeah, if you get something like that, let's try it. 25x squared minus 36y squared. Well, yeah, that's 5x and that's a 6y. So we put it in like this. 5x times 5x will give us 25x squared and a 6y and a 6y. Well, yeah, 1 plus, 1 minus will ensure the middle terms cancel. You should know that if there's a plus sign in there, this is prime. Don't know if I've hit that enough, but there's no, if that's a positive sign, these two can't be opposite signs, which means the middle terms can't cancel. Some other things on special cases that you should be aware of. If you see these perfect squares in this sort of setup, like 25x squared plus 80 2x plus 64. Now look at that, 64 and that. It is possible, instead of going through this AC method, that if they're perfect squares, it might be a 5x and an 8 times itself, or perfectly squared. Now they can be the same thing because, oh my goodness, there's a middle term in there. All you have to do to check this is, yes, 5 times 5 is 25. Good, that'll work. The middle term comes from 5 times 8, 5 times 8. That's 40 plus 40 is 80. That's how you know it. Officially, it looks like this. When you take and square a binomial, it looks like this. A squared plus 2ab plus b squared. That is this number times this number and doubled, because there are two middle terms in the middle. If it fits this form, you might be able to get away with that. That's kind of a lucky shot, but they set them up so that they can be identified by students. All right, let's clear off some of this and look at some of the other special cases. All right, difference of squares, and then we just did a perfect square. It's kind of a special case. Perfect square. That is a perfect square trinomial. Okay. So let's look and see what the other ones are. Some of you guys have seen something like 27x cubed plus 64 or something like that, where these guys are perfect cubes. Well, let's look and see where these come from. So actually, this is called the sum or difference of cubes. Let's put it down here. Sum or difference. Notice with squares, you can only do it with the difference, but this is with cubes. Now, let's look and see what happens. Here's a formula. If you have a cubed minus b cubed, a minus b times a squared plus ab plus b squared. Notice this is not quite a perfect square in here. You're missing the 2, but that's good to note. Let's see how this happens. Let's say we took something like 2x minus 3 and we multiplied it by 4x squared. I took that a and just squared it, plus 2x times 3 is 6x plus a 9. Let's see what happens when we multiply this out. The 2x goes through, and we have 8x cubed plus 12x plus 18. Okay. Now when the negative 3 goes through, we get a negative 12x. We get a negative 18. Oh, I forgot that 12x squared's on those. 18x on those. And then minus 27. And notice what happens. All of these middle terms cancel out, and we're left with 8x cubed minus 27. Yeah, so this pattern is actually, yeah, all this multiplication in here cancels out, and we're left with 2 times 2 times 2 is 8, and 3 times 3 times 3 is 27. So that is the pattern for a cubed minus b cubed. And it turns out that you can do a sum of cubes as well. And it looks like this. You just have to identify that the whole term here is a perfect cube, which you may have to learn 2 cubed, 3 cubed, 4 cubed, 5 cubed, and so on. But it's going to be a plus b, and then you have a squared minus ab plus b squared. Now I'm going to show you how I remember to do this, because I think it's pretty fascinating. If I have something like 125x cubed plus, what is it, 6 times 6 times 6, 216. There we go. Number one, I identify this as 5x altogether cubed. That's 5x, and that's as a 6. Okay, good. And I put a plus sign in there because I want a plus sign at the end. That's it. Now, I construct the rest of this. 5x times what would give me 125x cubed? Well, 25x squared would. And over here, 36. If this is 6 times 6 times 6, there's one of them. There's the other two. And then all I have to do is remember opposite sign, that guy times that guy, 30x. And that's actually what you can do instead of memorizing all these formulas. That's pretty good. There is a flow chart that may help you with organization of this and teaching this to students. And it looks something like this. You start out with a polynomial, and the first thing you do, Dun, da, 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 pull out the greatest common factor. So always, step number one, you've got to do this first. On your sheet, you should have greatest common factor as a method to try on everything. Then you go down and you say, okay, how many terms? Number of terms. Because that really determines how you're going to factor the thing. If there are 2 terms, then you have only a few options. You have a difference of squares, or you could have a sum or difference of cubes. That's really it, right there. Now, if you have 3 of them, let's do that one last. If you have 4 of them, then you're going to do the AC method. You're going to do what's called grouping. Okay, so that's breaking it up. So if you have 3, now you have a few other questions. If it has 3 terms, then you're going to say, oh, what is the leading coefficient? If it's 1, then your thing looks like this, x squared plus bx plus c. It's got 3 terms, leading coefficient is 1. That means you're going to do the try fast. Just an x there and an x there, factor c and put it in there. What if the leading coefficient is not equal to 1? Then just double check, because you don't want to do the AC method if you don't have to. Double check, is it a perfect square? Just double check this special case. Perfect square, remember, is one where it's a plus b altogether squared. Looks like this, a squared plus 2ab plus a b squared. Okay, so that's what a perfect square would look like, and then you would just factor it to look like that. Now, if it is not a perfect square, so yes over here and no over here. All right, let's put that down. And if it's not, then it looks like this, ax squared plus bx plus c. And the AC method is that you take a times c, and that means you split b. Once you've split b, you now have 4 terms, and it goes right back up there to grouping. And then you double check again. Let's write these over here so you can see them. A difference of squares looks like this, a squared minus b squared. And it factors into a plus b, a minus b. And a sum or difference of cubed, we'll write the sum up here, a cubed plus b cubed. Those are the 2 terms, and it gets back to a plus b. Then a squared to make an a cubed, a b squared to make a b cubed, and the minus ab to cancel out all those middle terms. And then if b is negative, you just put a negative there, and you're all good. So that flowchart may help people to see it. It's like dumping coins down there and they filter through. That may help.